Valves are found in every industry, from paper manufacturing to petrochemical processing. They come in all shapes and sizes and are as varied in their uses as they are in their design. Some valves may be operated by hand, while others require complex automatic regulation. Every valve, though, has one thing in common. They all control the flow of fluid. In this program, we'll explain how different valves regulate fluid flow, and we'll show you how to operate valves in the safest, most efficient manner. In this first segment of the program, we'll be looking at globe and gate valves. The gate valve controls flow by placing a movable metal gate across the pipe's opening. When the valve is fully closed, the gate is lowered all the way into the opening and the flow is stopped. When a valve is throttling, it controls the flow rate by restricting the amount of fluid that can pass through the valve. Gate valves are not generally used for throttling service because throttling causes high pressure to develop at the base of the gate, leading to excessive wear. In this cutaway gate valve, we can see its 5 basic parts: the body, the bonnet, the gate, the stem, and the hand wheel. The valve body can be attached to the piping by several different methods. Flanged piping may be attached to the ends of the valve body with bolts. A gasket is inserted between the flanges to prevent leakage. The bonnet and the body are also fitted with a gasket and are bolted together. In this gate valve, a hand wheel attached to a stem moves a gate up and down. The stem passes through a stuffing box located in the bonnet. A material called packing fills the stuffing box and seals off any gaps that might permit leaks. Toward the top of the valve, the threaded stem screws through a stem bushing, which is firmly attached to the hand wheel. Supporting the hand wheel is an outside yoke. The hand wheel turns freely but stays connected to the yoke. As the hand wheel is turned counterclockwise by pushing with the right hand and pulling with the left hand, the stem and attached gate rise and the valve opens. Turning the hand wheel in the opposite direction, or clockwise, closes the valve by lowering the stem and gate. Because of its design, this is called a rising stem valve. You can always tell if the gate is open or closed by looking at the position of the stem. Some rising stem valves aren't threaded at the top. The stem in this type of rising stem valve is threaded on the bottom, and it engages threads on the inside of the bonnet. The hand wheel and stem are solidly connected, so both the hand wheel and the stem rise together as the valve is opened or closed. In this type of valve, there is no outside yoke attached to the hand wheel. Some gate valves have stems that do not rise. The stem of this valve is solidly attached to the hand wheel. A collar at the bonnet end holds the stem in place. It cannot move up or down. As the hand wheel is turned, the stem screws into or out of the gate, raising or lowering it. The position of a non-rising stem valve cannot be determined by looking at the stem or hand wheel. There are different types of gates that can be used in gate valves. The most common ones are the parallel disc, the solid split gate, and the solid wedge gate. Gate valves have a matching set of seat rings located within the body of the valve. As the valve is closed, the gate descends between the seats and makes a tight fit, sealing off flow. Wear and friction occur where the gate and seat rings come together, which can result in leakage or make the valve difficult to open. The second type of valve we will look at in this section is the globe valve. The design of a globe valve does not allow flow to pass through in a straight line. The valve seat is set parallel to the flow, so the fluid must change direction as it passes through the valve. Globe valves are frequently used for throttling service because their parts wear evenly when partially open. In the throttling position, all of the disc and the seat ring are exposed to equal flow and pressure, so any wear that occurs is likely to be even. As a result, complete closure is still possible even after long throttling service. A globe valve is usually set up for throttling so that the flow is from below the plug, which tends to open the valve. This provides a more stable operation and eliminates slamming or closing as the plug nears the seat ring. Flow from the other direction would put pressure on the top side of the plug and could close it. Globe valves can be equipped with several types of discs, including the plug disc, the composition disc, and the conventional disc. The plug disc is the most common globe valve disc, and it comes in a variety of styles depending on its service. Composition discs are made of a flexible rubber-like material so that hard particles from the flow will not prevent a tight closing. Conventional discs are constructed of hard materials like metal or ceramics. Contact between the two hard surfaces will often break up particles deposited by the flow. Let's review how gate and globe valves are designed and used. Please stop the tape and turn to Workbook Period 1.